Welcome back. In the previous session, we have matched all the components and we have updated the netlist file with the actual footprints. Now, let us go ahead and import this netlist in the PCB new software. So, if you'll go back to the KiCAD new window, if you click on PCB new icon and the PCB window opens up. I have in fact opened it before, so that I wanted to make outline for the board, and this outline can be drawn using the edges option here. You need to select the edges option and then draw the required layout or boundary for the layout. Alright, so since we are designing existing board or the layout is predefined, we will not have to worry much about the form factor of the board, but in most of the cases you will have to consider a lot of other things, like the case in which the board will be fit, or the placement of components, or the ports, direction of the ports, on which side they should be aligned, and whole lot of other things. But for hobby circuits, will not have to worry much. You can just design the board according to the function. So once the layout, once we have an outline for the board, the next step is to import the netlist which we have created before. And to import the netlist, click on the read netlist icon here, and then browse the netlist file in the same project directory or folder, and you can click on read netlist, read current netlist. Now you should be very careful at this point, because it should not throw up any errors when you read a netlist. So you'll get errors if there is mismatch in the footprints. Say for example, you have a 3-pin component and you assigned a footprint with just 2 pins, so it would throw up an error. Or if there are some other types of errors with the footprints, if the footprints are not proper, again it would throw up errors. So it is recommended that before proceeding with this step, there should not be any errors after reading the netlist. Alright, so here we do not have any errors, so we'll just proceed. Now, since I have already drawn the layout and we know the dimensions, the components which we have read will come up in a particular corner. Alright, so when you read the components in KiCAD, they are grouped, all the components are grouped together, and it is important to draw the outline so that we can spread out the components with an option, and that option requires that there is an outline for the board. And to spread these components, just click on the mode footprint. So it is manual or automatic, so you can just click on it and then right click inside the edges, or you can just right click, then select the option global move and place. So in that, if you select move all modules, so all the modules will spread out, and they will be just spread up and lined. So it just asks for confirmation, then it shows up that all the modules are spread. Now if you observe here, you would find that there are interconnections shown with the white lines. So this is called the rat nest. So this is in fact the netlist, which is showing what should be connected where, or which component should be connected where. So at this point in time, so you can forget about the schematic, and you will have all the connections that are required will be shown by the rat nest. And so if you, while placing the components, you can go ahead and turn off the rat nest with this particular option. So now these are all the components in our design, and uh, before we proceed, I would just like to show you the placement of components for the Arduino Uno. So here is an image file that shows how the components are placed in Arduino Uno. So here is the microcontroller, and these are the headers. So these are the headers. This is the power jumper. This is the reset enable, which we have not placed in our design. So there is no jumper in the in our design, but there is definitely a switch and all other components. So this is a typical Arduino Uno layout. Alright, so we'll go ahead and place these components according to the layout of the board. Now I'll just pause the video, arrange it, and you to do while I'll be doing here on my end. And when we come back, we'll see how we can route the board, what are the basic guidelines that we need to follow. There are some design rules that are required to be followed, and all other uh, various small things. So I'll come back in a while when the components are placed. Alright, so I have placed a few of the components referring to the layout diagram of the image shown here. Now just wanted to show one other feature that was included in the recent release of KiCAD. Now in all the layout that I've done, I've referred to a different layout for for the placing of components, but often you do that referring back to the schematic. So now, for example, this capacitor over here, I do not know exactly as to what part of schematic it belongs. So what I can just do is I can click on it and go back to the schematic, and the pointer would go to that particular capacitor. Let me just try one time here. Say I want to find C1 in the layout tool. So I'll keep the pointer here, and in the layout tool it would come up to C1. So this is a very handy feature. Now C1 is the power supply capacitor, and we want it in the power supply section, so I'll place it somewhere here. Yes, this looks fine. And again, all the shortcuts or options that work with the schematic editor work even with the layout tool. So again, M moves the component, R rotates it. All the basic commands work here as well. So here we can go ahead and place the remaining components. Now let me refer to the schematic here. Now these two capacitors we need to place near the CP2102. So let me see where the C3 is. So here is C3. So let me place it here. So we have ample amount of space on this board to freely place the required components. So it's showing C4 to be here. Let's see where it is. So you can even hide the values so that you can clearly see the reference numbers. And if you need to find a component, you could also hold down the control key and hit F to find an item. So C4, it is already placed, so I can move it a little near to this. Alright, so these are the capacitors. Now let's place the two we have not put the LEDs for RX and TX, so these should be some other resistors. Yes, this resistor is associated with the reset pin or the reset switch, so let us just put it over here. There should also be a reset capacitor, as no, we have not put a capacitor, so this is switch and a resistor for reset, so that's fine. Now we'll see what the remaining components are. What is D2? So D2 is the LED, and there is a 470 ohm resistor adjacent to it for the power supply. This is R1. Alright, so the D1 is again the diode for the power supply. So let me place it here, and the only remaining components are C6 and C5. So let's see what those are. So C6 and C5 are the capacitors associated with the crystal. So let me place them near to the crystal. Alright, so this is the actual layout of the board, and we have missed a LED which is usually connected to one of the digital IO pins for the Arduino. So let's refer back to the original schematic and find out where that LED needs to be placed. So appears that the LED should be on the pin number 13 of the Arduino board. So let's place a LED on pin 13, but to add anything to the layout, we will have to go back and edit in the schematic and reread the netlist. So we'll just do that. So here is pin number 13. So pin number 13 is, again, we're referring to the Arduino pins. So uh, these are 1 to 8, and then this is 9, 10, 11, 12 and 13. So pin 13 seems to be here. Let me just verify that with the actual design. Alright, so referring back to the schematic, we see that the LED is connected to pin 7 of the power connector, or sorry, to the digital IO connector. So it is in fact pin number 8 of the Arduino. So Arduino uses a different set of pin numbers, I mean analog and digital input pins. So A0 to A5 are the analog pins for Arduino, and 0 to 13 are the digital input pins. So it is connected to port B5, or pin number 8 of the Arduino. So we need to connect a LED to that particular pin. So going back to the schematic, so here is the pin number. So this is the last pin, port P5. Yes. So we need LED on this particular pin. So we already have a node or wire coming. So let me just place a wire from here, and then we need a resistor. This is about 470 ohms, and a LED. This goes to ground. Alright, so whenever we add a component, and this often happens in when you're designing, that you need to add or remove some components. So when you do that, again we need to redo all the steps. I mean, we need to annotate it so that these will get their numbers, and then we have to regenerate the netlist file. So click on netlist and click on save. We need again to close the existing CVPCB window and open it again, so that the new components reflect up in the design. So as we see here, so we have the resistors and LEDs. So again, the package is SM1206. And again, you need to save it here. Now going back to the layout, we need to read the netlist file. So you can again browse it and read it. So you should find two extra components at the bottom, which we have here. Alright, so D3 is the LED and D4 is the ground. So on the layout, let's see where they need to be placed. So this is power LED. So this is the LED connected to one of the port pins. So let's just place these components over there. Alright, so in this way you can make changes to the schematic and import those components by assigning them in the CV PCB. You can import them in the layout. And thanks for watching. In the next video we'll see how we can draw the actual layout, and also we'll discuss a few design rules.